Hello everyone, welcome to Team 2 presentation. Today we are presenting StressOut, depression detection application. We're going to talk about our project, we're going to talk about the problem that it's trying to solve, we're going to describe our MVP and all its attributes, including product backlog. We're going to talk about our acceptance criteria and user stories. We will describe what happened in Sprint 7. We're going to have test cases linked to that. We'll have team metrics for every sprint, application screenshots, and our machine learning model description, API retrospectives, and plans for future development. So meet our team. Omkar, he's our developer and database administrator. Lucien, he is a lead software engineer. Shivani is a developer. Wangbo is a developer, myself, developer and project manager, and Sidar is the developer. So from last time, Professor made some comments that we ought to improve. So we've improved team velocity and sprint burn down charts. We have improved the burn down charts with story points using only Fibonacci numbers, as well as introduced ideal burn down line. Also, we've made improvements to problem statement and project description. They were too big in size, so we've cut them up just to reflect the essential parts that our application is trying to solve. This is our project description. So, StressOut is an application detecting early signs of depression based on users' pictures and quizzes for customers who want to manage their mental health. StressOut app is a mobile app that analyzes users' image and quiz results and provides accurate assessment, unlike traditional way of visiting specialists. So our application provides accessible, accurate, and daily measurement of person's mental health. So we are developing a depression detection system that uses artificial intelligence model to analyze person's face with images or current mood with text to help find depression signs. Our detection system is trained with a unique dataset depression faces from messages and images. We believe that certain linguistic traits can be linked to possible depression symptoms as well as used to forecast the self-destructive behavior. The training result we want to achieve is the system that is capable of analyzing the input from users and detect the type of depression. So depression is a big problem right now. It's a prevalent mental health disorder that affects millions of people worldwide. It usually affects people with sadness, hopelessness, loss of interest in daily activities. So it's basically a big impairment of person's ability to function and can lead to a range of physical and emotional problems. Therefore, an early detection is a very important step to make sure that effective treatment is assigned and that it can reduce the severity and the duration of symptoms and improve person's quality of life. However, we right now we are encountering the difficulties with the traditional methods of detecting depression. So right now you will have to go to the doctor, you will have to visit a psychiatrist, make an appointment, and also it's very expensive. It's not that everyone can afford it. Therefore, there are a lot of barriers right now for a person to get an accurate mental health assessment. As a result, there is a need for an objective and reliable method of detecting depression. Our solution is to use the machine learning algorithm to analyze various data sources, such as pictures with facial expressions, psychological signals to identify indicators of depression. This is our team working agreement. We've been sticking to it since Sprint 1. Weekly meetings at the same day at the same time. Everyone came on time. We've never had any problem with that. Let's meet our personas. So Jack is a 35-year-old software engineer who has a history of depression and anxiety. He often finds himself feeling overwhelmed at work and he's struggling to balance his job and personal life. He wants to find a way to manage his symptoms so that he can be more productive and happier. This is a very typical picture of our potential clients, of our potential users. Sarah is a 25-year-old graphic designer who has been feeling down for the past few months. Despite her successful career and supportive friends and family, she feels unfulfilled and struggles to find joy in her everyday life. She wants to find a way to manage her depression and is open to using technology to help her to do so. Lisa is a 40-year-old stay-at-home mom who is feeling overwhelmed and exhausted. She is struggling to keep up with the demand of taking care of her children and household, and she's often feeling that she's a failing as a mother. She wants to find a way to manage her stress and feelings of inadequacy. And finally, Tom, he is a 50-year-old small business owner who is feeling stressed and burned out. Despite success of his business, he is feeling overwhelmed by the responsibilities and pressures of running it. He wants to find a way to manage his stress and anxiety so that he can enjoy his success and have a better work-life balance. So let's see at the MVPs and the technologies are in use. So our minimal viable product will have a homepage with welcome message that briefly introduces the app and its purpose, the button or link to create an account or login if you already have one, a list of features and resources available within the app, and a prominent call to action encouraging users to take a self-assessment or start tracking their mood. Profile history of consultation is a section where you can edit your personal information such as your name, email address, and password. An image upload and take pictures, a camera button that allows you to take picture directly within the app, a gallery that allows you to upload pictures from your camera roll, an option to add caption or notes to each image to help you remember important details or context, and a recommendation, a dashboard that displays any recommendations or next steps based on your self-assessment results, including suggestions for lifestyle changes, self-care practices, or professional treatment options. This is our prototype. The final product is a bit different from the prototype. However, we wanted to show how development has evolved over time and what we've came to at the end.
Greetings, I'm Shivani Chavan, a developer on our team. Our project leverages including TensorFlow, Keras, React Native, Render, Fast API, and Firebase. This is the conceptual architectural diagram of our project. Let me break down the architectural diagram. First, there is an user interaction. As a user, you engage with the iOS app designed using React Native. This app serves as a platform for depression detection. Second is the data input. Upon opening the app, you provide relevant details and upload a photo. Data storage. The uploaded photo is securely stored in Firebase, ensuring reliable data management. Then there is an analysis process. The fast API and render technologies come into play for the analysis phase. These tools work collaboratively to process the uploaded photo, implying the advanced algorithms based on the TensorFlow and Keras. The last step is depression detection. The result of the analysis is then presented to you, indicating whether the photo suggests signs of depression. So, in overall summary, your journey begins with interacting with the React Native app on our iOS device. The app collects your details and photos, which are stored in the Firebase. The analysis, powered by the fast API and render using TensorFlow and Keras, delivers insights into the potential presence of depression based on the uploaded photo. This comprehensive architecture ensures a seamless and effectively depression detection experience. Next is our sequential diagram. A sequential diagram illustrates the interaction between different components over the time. Let's outline the sequential diagram of our StressOut app, that is the depression detection app. User interaction. User interacts with the iOS app, providing details and uploading a photo. Data storage. The iOS app calls Firebase storage to store the uploaded photo securely. Analysis process. The iOS app triggers the analysis engine to process the uploaded photo using fast API and render. Depression detection. The result of the analysis is written to the iOS app. Result presentation. The iOS app presents the depression detection result to the user. Next is the UML class diagram. In UML class diagram, there are almost 5 attribute user, there which contains name, details. Then there is a method interactive with a app, iOS app, React Native. Method open app provides details, upload photo, Firebase storage. The method is store photo analyze engine that is using Firebase and fast API plus render. Then there is a method process called photo process. There is depression detection, attribute contains depression status, method contains present result, and photo. There is the other attribute called photo that is the image data. Thank you.
Hi everyone, my name is Yuxiang. Let's talk about the machine learning model. So in the first place, we collected a dataset containing over 2,700 facial images classified by happy or depressed. So we did some pre-processing for the image before training the model. We split 70% of the dataset as the training dataset and the rest as the testing dataset. After resizing and grayscaling the images, we were able to get rid of distraction, use this data from the images, so the data being fed to the model will be clear and it allowed the model to perform better. In addition, we built this convolutional neural network for training a machine learning model. It has input layer, hidden layers, and output layer. This neural network can capture the traits and learn from the images. This is a chart of the training process. The neural network used the training dataset to train the model and used the testing dataset, which is unseen, to validate. Eventually, we got a model which has 97% accuracy in training and 94% accuracy in validation. So, in theory, if you give this model some random facial images, it can tell you whether this person in the image is happy or depressed with an accuracy of 94%. After that, we tested the model using my selfies, and it worked pretty well. The predictions were all correct, and we were achieving 100% accuracy. Later, we built an API with this machine learning model integrated. We went through packaging the system into an API, configuring the RESTful services, setting up render environment. By the way, Render is a cloud computing platform that allows you to deploy web applications. So we solved the libraries in compatibility and finally deployed the API on Render. This is a terminal on Render showing the process when deploying the API. It started from uploading build, deploying, and finally we got this UVcorn running on HTTP 0.0.0.0, and it's running on 10,000 port. So what Render does is it exposes this port on the internet so we can communicate with our API. Here we have the URL to interact with the API. So what we can do is to put this link in the browser and hit enter. If the request is sent successfully, you will receive a message saying, "Hi there, you reached the endpoint." And this message was predefined when we built this API. We also did some testing with facial images. In this example, we send a post request along with a JSON file that contains an image of grinning clown. This image was encoded in base 64 format, and after almost 16 seconds, we got a response saying the probability of depression is 1%. Thank you.
So now let's do a quick review of all the sprints we completed before. So this is sprint 1. We didn't have stories in sprint. As you can see, they are all the tasks. We came up with our application idea. We established team agreement. We established team rules and a weekly meeting. And also we set up development tools. And Next is Sprint 2 recap. We start to work on some features about our app. Of course, is some basic feature for this sprint, like we complete the user page and customers can register themselves to the application so they can log in and they can see the user page, and also they can log out so that they can have their privacy in the app. And now it's a sprint to burn down chart. It's a little behind when the sprint starts. There are lots of work to do, but luckily we catch up in the middle, and in the end we finish them. And now it's sprint 3. In the sprint, we further complete some new features to make our app more professional and useful. For example, now customers can create their own profile. They can store their basic information, and customers can browse all the servers provided by the app so they can know what to do next after logging. And most importantly, they can take pictures so they can start to analyze their mood. And also, they can get some recommendation for their mental health from the app. And this is the burn-down chart. What we actually accomplished was pretty much like what we wanted. So you can see we basically sticking to the plan. Now it's sprint 4. We finished some important features as well, like customers can upload pictures from their phone so they can finish their profile, and now they can take quiz to understand their states of mind, and also they can track their mood. And also now we start working on the technical paper, and this is burn down the sprint 4 burn down chart. As we know, this is a last semester for SC-691, so we have a lot of work need to be done. That's why we behind the ideal line. Now come to this semester. First is sprint 5. In sprint, we start to focus on the backend. So as you can see, we finish the machine learning model. We receiving user details and results to the Firebase database. We receiving user information using image and information to the Firebase storage, and also we finish some stories like now the customers can add note to their pictures, so it can help them to remember the important details. And next is sprint 5 burn-down chart. At first we have some problems need to fix, so we stopped for a while. And after we discussed that and what to do, we finish the test as fast as we can, and we finish them all in the end. Here comes to sprint 6. We make the API call. We further improve the UI of the app, the backend of the app, and also improve the database on Firebase. And you can see the sprint 6 burn-down chart. And finally, here come to this sprint 7. In this sprint, we add some new features like, as a user, I want the app to display correct information across all pages. And as a user, I want to see the instruction for analyze image. And of course, we finish the technical paper. So here come to the stories and acceptance criteria. First, I'm in the role of the customer. When I open the app, then I want to see how to analyze image. And I click the question mark, and I can see the instruction. User story is as a customer, I want to know how to analyze image so that I can know which kind of pictures I should upload. Next step. Now the test cases. I will tell the first two for example. The first one is a test case for user page. The key is StressOut and the ID is test75. And here is test data. The expected result is customers can know how to see the instruction. The actual result is after login, question mark is shown behind the Analyze button is passed. The second one is also test kits for user page. The key is StressOut and the ID is test76. The customers can read the instruction, and the actual result is click the question mark button. The page shows the instruction also passed. And the complete and not complete stories and text. Because it's a last sprints, we have to finish all of them. So as you can see, it's all done. So now it's team velocity. The table shows from sprint 1 to sprint 7, all the story points we completed. And in this sprint, we totally complete 25 story points. And as you can see, there is a right line in the middle. It's average line. It's totally 20. And now is sprint 7 banner chart. We did much in previous sprint, so we don't have much work in this sprint. So as the chart shows, we basically stick into the plan and finish all the stuff.
Hi, good morning to all. My name is Omkar and I am the developer on this team. And today I will give you a walkthrough on the app screenshots. So let's start. So as you can see at the right side of the PPT, it is the home screen. Basically, we have 5 functionality buttons in our app which serve different purposes. But I will talk more about that in the upcoming slides. Let's talk about the home screen, which we can see. In this, we have given a warm welcome message to every user who logs into our app. And with that, a bit of functionality, what our app is about and what it focus on. So this is the home screen. Moving ahead. This is the different screens in our app. Talking about the second screen, which is the quiz screen, in which we prompt the user with five questions. And according to its answers, we give an alert message if he or she should consult a health professional or not. Moving ahead with the post screen, in which this is the main MVP of our app, in which a user can upload his photo and the picture is sent to our AI model for the predictions. And our AI model is trained on a large data set of facial expressions. So we can predict if he or she is in depression or not. And we display the results on the screen, as you can see. Moving ahead with the notification screens, we have given links to many articles and videos for breathing exercises and meditation exercises. So the user has the useful resources to do the exercises accordingly. Moving ahead, this is the user details screen. In this screen, user can edit and save profile information like name, gender, age, date of birth, medical history, and active history, in which the this page also records the information such as the previous quiz scores, where the user can keep a track of things what he or she has done previously. So this is basically the user's data is saved on here. Save with concerns to sprint 7, the final sprint 7, we have made changes to some UI, like we have made changes in the login screen, we have added the loading functionality, and we have added a main instruction page when so the user has a reference point and a guidance how he or she should upload his image or not. Near the analyze image button, we have added a question mark button where the user can click and get a guidance of how he or she should upload the image to get the accurate results. Moving ahead, Firebase authentication. When a new user creates an account using a Firebase authentication in our app, the user email address and a unique user ID are automatically generated and stored securely in the Firebase server. Moving ahead, so to maintain a separation between different users' data, we create a separate folder for each user in our Firestore with a user UID associated with the folder. So we have the differentiation between every user with a reference to their unique IDs. And that's all. Thank you.
Hi, this is Siddharth, and I'm going to tell you about the plan for future improvement. One, introduction to reinforcement learning to the model. This will enable constant improvement of accuracy for any given individual. Two, introduction of video conferencing with mental health professional. The app should strive to become one-stop shop for people to diagnose and solve their mental health issues. Three, posting the app on Google Play and App Store. Release the app to the public. Thank you.
Hi guys, my name is Omkar and I am a developer on my team. So I will give you a live demo of our StressOut app. So just to give you a brief about the tech stack about our app. So in coding languages, we have used JavaScript, HTML, CSS, and Python for API, and frameworks such as React Native for our mobile application. In the backend database, we have used Firebase. And in addition to that, for API, we have used Fast API, and cloud hosting, we have used Render. And in addition to that, we have used tools such as Slack, GitHub, Visual Studio Code, and Postman. So let's start with the live demo of our app. As you can see on the left side of the screen, this is the login screen of our app, in which if the user have the login credential, he can directly log in into app, or he can create one by clicking on the don't have login credential, and he can create his credential in the sign in screen. We have already created the test credentials, so let's jump into the app. Once the user logs into the app, we redirect him or her to the home screen, in which we have provided a warm welcome message to the user and what all functionality our app does. We have given some brief about it. Moving ahead to the next screen, it is the quiz screen, in which we have prompted 5 questions to the user. So the user could answer it accordingly, and he can decide. We give a alert message that if he or she should go to a healthcare professional or not, according to the answers. For example, if the user clicks yes, 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 yes. So here is the alert message that you may be experiencing depression. So you can consult a healthcare professional. Moving ahead to the next screen, which is the notification screen, in which we have given the useful links for breathing exercises and meditation exercises, such as if the user clicks on the box breathing, we redirect it to the article where a brief about the box breathing exercise is done. The user can just read through the article and get useful knowledge about it. And we have provided some YouTube links of meditation also, in which the user can watch the video and try it itself. Going ahead to the last screen, in which this is the profile screen in which user can update his data, like name, gender, age, date of birth, medical history, and so on. I will just update it really fast. And 17 slash. And once the details are updated, it gets automatically reflected in our backend, which is the Firebase. Let's move on to the MVP of our project, and this is the post screen, in which user can upload images, and it will be sent to our AI model, which can predict if the person is in depression or not. In this screen, we have 4 functionality button, in which the user has the ability to pick an image from the gallery. He can take the photo from his camera itself and analyze image. So this is a virtual phone, so I cannot really access the camera, but on a physical phone you can. And in this, as you can see, there is a question mark button near the analyze image. In this page, we have provided some instructions for the user, so the user can read them and take the image appropriately, so he or she can get the results accurately. Moving ahead, let's try out the app. As you can see, this is a image of a happy man with his expressions. And the processes are taking place over here, as you can see. So the probability of depression is 3%. Let's check this image. The probability of depression is 99%. So this is our app, and this was a live demo of the app. Thank you.